Good evening, sir. Jesse Crawford here for my final post-lab video reflection. I thought these were a fun little ending to the course. I actually got my son involved. He's actually still back there working on experiment number 2. This time he's doing it by himself. He helped me throughout the first time. Now I just got him back there separating S's by themselves, doing his own little radioactive decaying. So with this one, the two exercises, one using the flashlight off the CD, which also using the grader, the diffraction grader, to split the laser light into different fractions, along with seeing the stuff on the CD from the flashlight and the laser pointer. With the safety portions of this, obviously the laser pointer in the eyes. One of the things that I noted for safety was actually when you're using the CD and you're shining the laser light onto the CD, in my experience, the laser light shot off in multiple different directions and multiple different laser lights and points and refractions and stuff like that, just going all over the place. My son really enjoyed it. So for my results, when I shine the flashlight on the CD, you can see the visible spectrum of lights from red all the way to violet in order, just in a line, kind of like a little rainbow on the CD in 2 spots, wherever it hit. You can also shine in different angles. You get the different orders from the red to, starting from the center, going out, either red to violet, or going from the center out, violet to red. But you can see all the colors with inside that. Then the laser pointer. I really didn't understand what was going on with this one, other than just a red dot being shined on it. I didn't see anything, I guess, that would be part of the experiment or the content. But I did see it, refracting all over the place again, trying to ensure that I pointed it out and away and hope it reflected off the wall away from me rather than back into my face and my son's eyes. With the grader, the laser shot through the piece and shined the 2 extra dots, the first order dots, and I measured both of them from the center dot all the way up to both of them at about 18.6. I actually had to do a little adjustment to get them even on both sides. It was about 18.6 centimeters. And then doing the L measurement, I then got another 18.6 or so from the center or from the first order dots to the center of the grader. With the Skittles experiment, started with 58. I've sent a photo along with this in my submission. So I started out with 58 Skittles, started those out as the parents, and also the photo I took, I separated my Skittles back into the original number I poured, because basically I got 35 face down. I'm just eliminated well over half of the Skittles from that point on. So I was like, man, I just want to show a visual of what it looked like with my results, plus the visual of 35 Skittles face down rather than face up, and a big number being basically decayed away. From there, it slowly went down about half or so, dropped to a 12 and 11 from parent to daughter, and then a 5 to a 7 parent to daughter, 2 to 3, so on and so on. I even got one where I got 2 up, face up, so I got a 0 daughter. So I went from a 3 to a 0 to a 1, and then a 1 for my daughters, atoms. As far as why did the spectrum from the laser light and the flashlight differ? Well, the flashlight, so the laser light's shining a red light, so I felt like I was going to get, I guess if I'm looking at it from one of the content that we had done, like a green rather than a red. I'll actually have to look at your video. For some reason, I skipped your video that you normally post during these, and see what exactly was supposed to come from it. The white light, basically, it was shining the light on there, and it was bringing to light the visibility of all the lights that are shined off of that prism, basically, and shooting it back up, because on the CD it's just clear plastic in a way that is on the back of that, and so it basically makes a prism, causing light to reflect through it, causing all the spectrum to be visible from the single solid light. What is predictable about radioactive decay and what is unpredictable? So I feel like in my experiment with 35 to 23 on my first dump, basically how, like, I guess is unpredictable is how much actually decay is going to happen at different rates, at different times, at different periods throughout the time that it's being decayed away by the radioactiveness is going away and whatnot. I felt like that's kind of unpredictable, but that's just based off of my results here. It's probably more as, and that was again just my first one, so maybe something could decay, the radioactiveness could decay at a rate quicker at one moment based on some sort of environmental thing that's happening to it, or just the way it is at that exact moment in the world. Maybe it's the temperature, I don't know, something of that nature. What's predictable, I guess it's going to decay. I guess since, I mean, this isn't something that's relatively, I mean, people have been working on it for a minute, and they can almost, like, and that's another thing too, is like they say that, I forget the one I was working on, but was it carbon 14 or something of that nature? I forget exactly. Says it takes 5,730 years to decay. I feel like that's just a giant guess. Obviously, an educated guess. They're having something that makes them think that that is what the end date's going to be for that radioactive element. And to think 5,000 years, I mean, we haven't been doing this we have not been experimenting with these radioactive elements for 5,000 years, let alone, like, that's extraordinary amount of time for the little bit of time that we've actually been experimenting and exploring this field of chemistry. And I just find that I won't say outrageous, but to think 5,000 years for half-life to happen on this one atom is just absurd. I feel like if we keep at this rate, and I'm not an environmentalist by any means, I'm starting to become one based on just this course and the outcome of things, especially from my project that I did. But I really think that we need to take a big look at it. And I guess our discussion post had a lot to make me think about that too, like ways of getting rid of it, but off topic. Anyways, so the most useful, supporting the understanding of the content, the Skittles was very useful in understanding the basically half-life aspect of it, with decay relatively equal to half every time it poured out. I mean, that's just probabilities. When you're doing something of that nature, pouring out a number, you're going to get roughly half in general. Yes, you're going to flex one way or the other here and there, but probable, you should get it right around half on all of that. And so if I was to look at this, and let's say that each time I did it, it's 100 years, or let's say 1,000 years, I guess. So to get down to the entire element being gone, at 7,000 years is how many times it took it to get from where it was at its max to basically eradicated. The least useful supporting lecture content. I had one, but I totally forgot prior to this. Oh, I'm just gonna say it was the lab quizzes. Sometimes those questions out there are just like, I just don't understand where they come from sometimes, but that's me. Maybe I'm not finding the things, and really it has to do with more of, like, I guess the safety and the setup of your experiments and things like that. I mean, just based on one of the questions, I mean, I just feel like sometimes it just, I don't know where they're giving me the answers to these things. They're not necessarily based on the content. They're based on, just like safety precautions, which is what we should handle every single day. I understand. Well, sir, that's my video. I appreciate your time.